What's up, guys? We're going to continue here with Chapter 5, Section 2, where we are solving systems of equations. And today we're going to be looking specifically at solving equations by substitution. So it says here to use the substitution method of solving a system of equations, you could solve one of the equations for one of the variables substituted into the other equation. This is what this particular method is. So let's keep moving. When Christmas music comes out too early, which is, we're not even to Thanksgiving yet, and I'm hearing it, this is how I feel. Oh yeah, little grumpy cat. That guy and I, we got a connection there. Okay, so using substitution, it says solve the system by substitution. Anytime you have one variable that's already isolated, that's the one you want to focus on. So this says that y is equal to 4x minus 1. That means that y is the same thing as 4x minus 1. So I'm going to take this whole thing right here, and I'm going to plug it into that y. So I have 2x plus 2, and instead of writing y, because y is 4x minus 1, I'll write in parentheses 4x minus 1 equals 3. Don't forget the other part of the equation. So here I have an equation. I need to solve that for x. So I'd use the distributive property. And I get 2x plus 8x minus 2 equals 3. Combine some like terms. 10x minus 2 equals 3. Add 2 to both sides. And we get 10x equals 5, and then divide by 10. We get x equals 1/2. Now, after I find out what x equals, I'm not finished with the problem. I still have to find y, because remember, the solution to a system of equations is an ordered pair, an x value and a y value that makes both of these true. It's where their graphs intersect. So if I know that x is 1/2, I could substitute it into either one of these and figure out what the y is. I'm going to use this one because the y is isolated. So y is going to equal 4, but instead of x, I'm going to write what x is, which is 1/2 minus 1. Here I multiply these things. Y equals 2 minus 1, so that y equals 1. So my ordered pair, it's going to be 1/2 and 1. There's my x and my y value. That's the answer. Now, the cool thing about this is you could actually plug these in and check these to see if these solutions work. I'll just do that real quick with mental math. So 2 times 1/2 is 1, plus 2 times 1 is 2. So 1 plus 2 equals 3. That works. And we already know that works because that's what we solved for. So you can check these. I would encourage you to do that. I'm not going to be doing that on the video for the sake of time, but again, I encourage you to do that. So here's one for you to try. Go ahead and pause and give that a go. The answer will be up in 3, 2, 1. All right, so here's what I got with the x being -1, the y 0. That's my ordered pair. Hopefully you got the same thing. All right, so solving for a variable and then using substitution. On these particular ones, notice that a variable isn't isolated, but there is one where it's pretty easy to isolate. This one right here. If I add 3x to both sides, I could very easily isolate that y. So now I have the y isolated, and I could take this and substitute it in for this y. So I'm going to have right over here, so I have room, negative 9x plus 5, but instead of y, I'm going to write 3x plus 4. And that all equals -1. So then I distribute negative 9x plus 15x plus 20 equals -1. Combine these like terms, so I get 6x plus 20 equals -1. Subtract 20. 6x was negative 21, divide both by 6, and x equals negative 3.5 or 3.5. All right, so there is that. Now, after we figure this out, remember we got to substitute back in here, so we'll go ahead and do that. So I have negative 3 times negative 3.5 plus y equals negative 4. Notice that I used the original here. You don't want to go and use one of these other ones. You got to be very, very careful with that. So negative 3.5 times that is 10.5 plus y equals 4. Subtract 10.5. You get y equals negative 6.5. So that your ordered pair is negative 3.5 for my x and negative 6.5 for my y. And again, you should substitute those in and check those to see if they work. These do, so we're good on that. Here's one for you to try. Go ahead and pause and give that a try. The answer will be up in 3, 2, 1. All right, I got negative 6, negative 9. Here's where I isolated the y from the first equation. Here's where I solve for x. Here's where I solve for y. So if you did not get that, try to follow along. All right, so here's where this actually comes into play. It's a useful thing, so let's take a look at this. It says Nia's phone plan costs $42 per month plus 20 cents per text. I'm going to go ahead and just write that out. Nia's is $42 per month. That's a constant rate plus 20 cents or 0.2 per text. And it says Rick's phone plan costs $45 per month and 10 cents per text. So he's 0.1 T plus 45. It says for what number of texts will their plans cost the same per month? This is the cost of Nia's plan. This is the cost of Rick's plan. I want to know, when does Nia's equal Rick's? Well, in order to solve that, set these two things equal to each other. So I have 2 tenths T plus 42 equals 1/10 T plus 45. I want to know how many texts there will be for that. So I go ahead and solve this. Let's see, I would subtract that first. All right, so T equals 30. That means there's 30 texts. And then it asks, what will the monthly cost be? Well, if there's 30 texts, I just substitute that into one of these. It doesn't matter which one. I'll do Rick's here. So Rick's cost is going to be 10 cents times 30 texts plus the $45. Well, that's $3 plus $45 for a total cost of $48. All right, so this is a two-part answer. This first part is that there are 30 texts, and then the second part is it's going to cost them $48 for that. So this is when the plans would cost the same. Here's one like it. Go ahead and pause and give that a go. All right, here's what I got. 10 texts for the cost to be the same, and that cost will be $44. All right, that's it for this one. So hopefully you took good notes. I'll see you in class.